Welcome to another math lesson. Today we're going to talk about the slope-intercept form of equations, and our goals, which there are actually two there. We're going to identify slope and y-intercept in this slope-intercept form, and then I want you to be able to graph lines using that slope-intercept form. So the graphing the lines using slope and intercept you've definitely done. And we have talked a little bit about the slope-intercept form, but we haven't really looked at it in any kind of, detail. That's the word I want, detail. So I just want to remind you that we have four types of slope, and you guys seem to do very well with that. Knowing that a positive slope looks like the one rising like it does, and a negative slope goes in the opposite kind of direction. And then of course we have our zero slope, which is horizontal, and we have undefined or no slope in our vertical. And I want to show you what each of these can look like in an actual equation. That's algebra, that's what we're trying to get into a little bit, just learn a little algebra, not a lot, just a little. So the slope-intercept form is what you see there at the top of the page. Y equals mx plus b. Okay, m is our slope. Remember we talked about that before, m, and we don't know why it's called m, but I want you to think motion. I want you to think movement. Don't think just a spot on the graph. Okay, when we're talking about the slope, we're not talking about a spot on the graph. We're talking about how steep the line is going from point to point. And the b in this equation is our y-intercept. So it is a location. And I have an equation there for you. We're going to graph that one in just a minute. Y equals 3x plus 5. And you can see the 3 is our slope. And whole numbers, remember, we got to convert them into a fraction in order to use them as a slope because we need another direction. Remember, the 3, or the top number of our fraction numerator, is the y direction. So that tells us how far up or down we're going to go. And then we need a horizontal one too. And if there's nothing listed there, if it's just a whole number, then we know that the horizontal direction, or the x direction I should say, is 1. Okay, so don't forget that. That's important. Then our y-intercept is 5. And the intercept is where the line crosses the y-axis. So really, it's at location 0, 5. So let's see how that works out. This is the same one. And first we want to do is we want to take the y-intercept, 0, 5, or we call it y-intercept of 5, and we want to put it on the graph. So there's our 5. All right. Then we want to find another spot on the graph, but the only way to do that now is with our slope. So we're going to go up 3 and to the right 1. And that's how far we have to go. And then we draw our line. It's that simple. Take a good look at that. Now, what happens if instead of being a plus 5, it's a minus 5? Let's take a look at that idea. How does that change things? We've got the same slope, but now the y-intercept is a negative 5. So what I want to make sure you're aware of here is it's not just the number. It's the sign in front of it, okay, or the operation in front of it. It's either plus or minus. So you have to include that. If you notice, I highlighted both the 5 and the plus in this one, green, all right, and I did the same thing here, the minus 5, highlighted it green to match what we've been doing. So you're going to start with, first of all, graphing the y-intercept. What do you think we're going to end up with? What kind of a line? How does it compare to our first one? Pause and think about that. Did you think about it? Okay. So hopefully what you thought about is, well, the slope is the same, but it's crossing in a different place. It makes sense, doesn't it, that they would be parallel. They're never going to intersect. Never. Never, never, never. They have lots in common, but they're never going to meet. Isn't that sad? Oh, poor lines. All right, let's look at another one. here's y equals, now what I've done is I took that original equation we've been doing, y equals 3x plus 5, and I changed the slope to a minus. So everything else looks the same as the very first equation, but now I've got a negative slope. So, first thing we do is graph the y. There we go, our y-intercept. But now our slope says minus 3. And what I want you to notice is one of those two numbers, either the 3 or the 1, has to be negative. Can't be both, but one of them does. So I took the 3 and I made it negative. I went down. That's the negative direction. But the 1 still is in the positive direction. And that completely changes the direction of our line. Okay, so remember, you know negative slopes go this direction. So if you see one, and if you see a graph, and it doesn't go in the negative direction, and it says negative in the equation, well, you know, we're trying to fool you. Don't fall for it. You're smarter than that. Okay, so now, here's one. There's nothing in front of the x. And I already gave it away because I left it up there. But if there's nothing in front of the x, we know, because we don't write it, it's just a 1. It's not a 0, because then there wouldn't be any x. And that's a whole other situation we'll talk about in a minute. But if there's just a 1, if there's nothing there, you know it's a 1. And then, of course, how do we turn 1 into its own fraction? Well, it's 1 over 1. So, one more time, I'm going to graph my my y-intercept. Now what I did here was I snipped off the bottom half of this graph and made it bigger so you could see it better, because when I'm graphing 1 over 1, it's very hard to see on these slides. So I made it bigger, and then we go up 1 and to the right 1, and then we have 2 points and we can graph our line. Simple. So remember, if there's nothing in front of the x, that means it's a 1. Okay. But what happens if there's a minus sign in front of the x? Take a look at that equation. Only difference between the two is that I put a minus sign in front of the x. So, again, if there's no number, that means it's negative 1. Okay? So it'd be negative 1 over 1, or 1 over negative 1. It doesn't matter, as long as only one of those ones is negative, not both. All right? So we're going to graph it. I didn't change our y-intercept, though. You see that? It's still plus 5. So the dot's still going to go in the same place. But this time, we're going to go down and to the right. Let's see. Go down. That's the negative y direction. We're going to go to the right because we're still using a positive x. And now we graph that line, and look what happens. Going through the exact same spot, and yet it's going the other way. Now, if you could actually get out a protractor and measure between those lines, you would find out it's a 90-degree angle they're causing. They are completely, what's the word? Perpendicular! Yeah, they're perpendicular. If the slope is what we call negative reciprocal flipped, but when you flip 1 over 1, it's still 1 over 1. So in this case, you can't tell that it's flipped. We'll get into that another day. But anyway, just so you know, this is a perpendicular line. Okay, now, here's a situation where I've got no plus b. Where's the plus b? There isn't any. I've got 3/2 x. We got our slope, 3/2, but there's no plus b. Well, that means b 0. In this case, right, it's just plus 0. So, there you got it. 0, 0. Let's see how this one works. We're going to start at the origin. Ta-da! Wow, that went far, huh? And then we're going to go up 3 and to the right 2. Up 3, to the right 2. And now we can graph that line. Connect the two dots. And that's it. So if you don't see a plus anything or a minus something, you know that the y-intercept is 0, so you're going to put the dot right smack in the middle. All right, you ready for another scary case? Here's another one. There's no x something, something times x. Well, again, it's just 0 then. It's that simple. But our y-intercept is 5. 5. Y is always 5. How do you graph y is always 5? Well, it's one of our special cases. You can see there's 5. Now, what kind of a line, which way will it go to make it so that y is always 5? Is that going to be vertical or is that going to be horizontal? Well, if you remember back to our little help sheet of all the different kinds, we said 0 slope, horizontal. Ta-da! So y is always 5 in this case. All right, so when you see that, don't panic. It's okay. We have no slope. It's just a flat surface. It's easy to walk on. There's no fighting the gravity because, you're on it, Okay. So, what happened here? We don't have any y's. Or we don't have any plus b's. Or do we? I'm so confused. Wait. Where is x always 5? Notice what I've said. I've already given you all the answers to my questions. All right. X is always 5. Well, let's see. Where's it cross the x-axis? Oh, I didn't even bother to put the dot on this one because x is always 5 in a vertical line. There is no slope. It is straight down. You're going to jump off the cliff and go straight down because there's no slope. There's nothing there to stop you. You're just going to go right off the edge. Okay, I know. I'm weird. All right, so remember these? See, well, this is what we just talked about right here. This is the one we just talked about. No slope. Remember? So if we see just an x equals some number, it's a no sloper. And if we see a y equals some number, it's a 0 sloper. All the others, positive, negative, and we've covered them all. So, are you ready? We're going to test you now. Number 1, which graph matches this? Y equals 1/2 x minus 2. Okay, number 2. This is one of those special case ones. Y equals -1. Number 3. We have a -6x. Y equals -6x minus 3. Which one matches? Last question. I'm going easy on you today, just 4. X equals -3. What was that case again? How did that work? Well, I hope you can identify the slope and the y-intercept in the y-intercept equations. And I know you already know how to graph. So, the more practice we get, the better you'll be at it. Thanks for watching. See you next time.